So guys, here are the some of the modification. This wire is actually 12 volt line, DC 12 volt. So the green is red, sorry, the green is live and the yellow is neutral, or you can say like that, the green is 12 plus 12 VCC and yellow is ground. And regarding this wire, you have to check once before confirming. Yes, the green here is 12 volt VCC and yellow one is ground, and here I have a single pole switch, and I will say the purpose of this switch later on. It is just similar to the normal operation of the switch, but I am here using this thing as dual purpose switch because a Wi-Fi router has it inbuilt switch. Here you can see, let me show this yellow button. Too many shadows. Where is it, man? Yes, you can see the yellow button. This is the Wi-Fi router switch. So the problem statement is that because of the ohmic copper loss in DC transmission, the voltage in cloudy days supposed to be 12 volt, but it is actually little less than 10 volt. And you know, Wi-Fi router consumes a lot of power. So to overcome that disadvantage and the problem of load shedding, I am using this DC to DC voltage booster circuit. Here the input is near about 10 volt, and I had adjusted the output of this potentiometer to give output of 16 volt DC. So this 16 volt DC is parallelly fed to this 12 volt 7.2 ampere hour Bharla battery. It is actually a UPS battery, and you can use this battery in your electric cycle by series connection. This battery gets parallelly charged. Green wire is plus, yellow wire is minus. So when this battery is getting charged, the 16 volt DC drops. Maximum it drops up to 4 volt. So when 16 volt drops and the maximum voltage drop is 4 volt, the rest of the output is standby 12 volt. Or you can understand by this way, when the battery 16 volt DC output is loaded with 12 volt battery and the battery is getting charged, it consumes some power, some of the power, and for that the voltage drops. And to supply the Wi-Fi router at the same time, I had turned it off just now because it was having some issue. The battery is not fully charged, so the output voltage is little less than 8 volt. So the standby output is near about 12 volt. This battery, when give is fully charged, the open circuit voltage is 14 volt. Again, if assuming that this battery is not in use, the Wi-Fi router is not consuming power from this battery, it is only using the direct supply from this DC to DC voltage booster module. So 16 minus 4, because 4 volt is consumed by this battery to get charged up, and rest of the 12 volt is supplied to the Wi-Fi router. So let's check. The Wi-Fi router is getting powered up. It is taking a bit time to get registered. Yes, it is registered, and the next LED is Wi-Fi. So here comes our signal. Again see, the registration is vanished because it is too much cloudy outside, so my battery is not fully charged, so I have to give some time to this baby to get charged up.